This is part one of an introduction to the Go programming language. This tutorial assumes that you already have some experience programming. So if you're a brand new programmer and never programmed anything else, you should probably start somewhere else. But if you know some basics of programming, this tutorial should help you get started with the Go programming language. So to start out with, let's go through some preliminaries. Start out with, why use Go in the first place? Okay, well, one thing that I've enjoyed working with Go is that Go has simplified pretty much every step of the development process. It makes the actual process of writing programs faster, easier, more streamlined. And that comes in every aspect, from the language to the build process. They've just really made it very tight and very workable. Go itself is actually extremely fast. It's based on the C programming language, and it's low level, but it doesn't slow you down low level. So anyway, that makes it extremely fast. It's built so that the compiler is able to optimize a whole number of things that are not optimizable in other languages. So it is comparable to, but not quite as fast as C and C++. But really, I think that in the actual practice of it, the Go programs that I've seen, Go encourages you to program in a way that actually is faster. So Go is also statically typed. That means that the compiler itself will do a lot of type checking. So this helps you. I've written in scripting languages and like PHP and Ruby and Perl a lot of my life, and I've enjoyed the flexibility they give. But the problem is that you wind up having to write a lot of tests to cover things that a compiler could have checked for you. And so Go, being statically typed, will automatically check a lot of errors for you. I would say about 80% of the errors get filtered out just from the type checking. Go also has built-in support for metaprogramming. So this is programs that generate programs. And we're not going to get into that in this particular video, but it's actually a really cool system, and later we'll go over it. Go also makes it really easy to build cross-platform. You can just tell Go what platform you want to build for, and it will build a program that will run anywhere. And then finally, Go actually makes it really easy to build concurrent apps that use a lot of different threads and use them very efficiently. So to think about Go, you need to imagine you took the group that built C. Now, if you're a new programmer, you might not be as familiar with C, but C was kind of what really launched the computer revolution, because it was fast. It was fast because it was low level, but also was helpful to the programmers. So programmers could easily build up abstractions. They could do a lot of things, but in the end, it was an early programming language, so it wound up being kind of crufty. And so these days, people don't like to program in it because, well, let's just say that compared to most modern languages, it's kind of ugly. But let's say you took the group that built that language and you gave them the benefit of the last 40 years of programming language insights. And then you removed all unnecessary features and you created a language that was built to scale as large as Google, but simple enough to keep in your head. And then you made a build system that made module fetching, compiling, processing, and sharing your code super simple. Okay, so that's kind of what Go is. Go, most of the creators were some of the creators of the C programming language. They now work for Google, and what they figured out is that a lot of the programming languages these days have gotten really complicated. And so it's actually, you can't expect that a programmer can remember all of the rules. And so what they decided to do, they decided to create a programming language that utilized all the knowledge from the last 40 years of programming language insights and build a language that was still simple enough that the programmer didn't have to spend a lot of time thinking about what the language is going to do, because they could hold all that in their head at the same time. Now, to show you Go, I'm just going to show you several example programs. So each of these programs are actually full programs. They compile completely from the screenshot, but each of them give you a little piece of of the Go programming language. So we'll start with a simple hello world-ish type of a program. So this is our first Go program. And so one thing to note about Go programs, so you can probably guess what all this stuff means. Package main, we have imports that pull in other packages. We have a main function, that's the entry point. It declares a variable and prints it out. So package main, so all Go code has to declare a package. You have to say what package you're in. And in fact, if you have multiple files in the same directory, they all have to be in the same package. Okay. Now the name can be whatever you want. Go actually has some, you don't have to worry about accidentally bumping package names because Go has some things to help against that, and we'll go over that in the lesson on packages. But you have to declare a package, and if you're an executable program, that package has to be main. Okay, that's how Go figures out where to find the function to run, is it looks for the main package. So then you import your libraries, and libraries are imported. Each line is a separate library, and this is the FMT library, which is for formatted input and output. And so again, we'll go into libraries in more detail later in a different video. So then we have a function declaration. So this is the main function. So the main function in the main package is the entry point to the program. So you can see here a variable declaration. Okay. So notice that the type comes after the variable name. So var indicates as a variable, then x is the name of the variable, int is the type, and then equals is the initializer. And then we have a function call. And since we're calling a function from a different package, it has to be prefixed by the imported package's name. So this is fmt.printf. The value of x is %d, and %d means the next thing we're going to pass in is a integer. And so that's our x. And so that when you run that, it'll say the value of x is 5. So anyway, so that's a first Go program. And also notice that the printf starts with a capital letter. That's because everything that you use from other packages have to start with a capital letter. And again, we'll go over that more on the video on packages. So now to build this program, let's say we call the file main.go. Doesn't matter really what the name is as long as it ends in .go. Then you just do go build -o and the name of the program, and then you can run it. So /myprog, if that's what you called it. So Go will compile everything in the directory together. So if you want to build all the different programs here, you need to switch out, you have to put them all in different directories because otherwise they'll all have the same main function. And so then it'll get confused as to which main is the entry point. And so you have to, so if you're going to build all the programs in here, you'll have to put them all in separate directories. So a little bit more syntax. This is the factorial function written in Go. So first thing we have, so you'll notice that we have factorial, and it has both a declaration of parameters. So the first parameter is x, which is an int. And then the return type just comes after the parentheses, and so it returns an int. So we started, the function name is started with a lowercase letter, so that means the function is only available inside the current package. Okay. So then here's an if statement, and notice that in Go, if statements do not require parentheses. So in the last program, we declared x as using the var, and that's perfectly doable. But here, we're assigning with :equals, and if you assign with :equals, that tells the compiler that it needs to auto figure out what the type of the variable is. So this x : equals 5, the compiler is going to say, okay, well, what type is 5? Oh wait, 5's an int, so that means that x should be an int. Okay, and so the result we're going to assign similarly. So it figures out that factorial returns an int, and so it's going to result itself is going to be an int. and then we can pass those variables to the printf function. Okay, and factorial, for those of you who don't know what a factorial is, a factorial of 5 is 5 times 4 times 3 times 2 times 1. The factorial of 6 is 6 times 5 times 4 times 3 times 2 times 1. So that's what the factorial is. And so this factorial is implemented recursively. So it basically says if you're at the end, return 1. Otherwise, return the variable times the factorial of the variable 1 less. So anyway, so that's this program. And so now we're going to go into a little bit more syntax about how we handle errors. Okay, so error handling, and factorial is not a really great example to show error handling, but nonetheless, we'll give it a try. So first of all, the way that error handling usually happens in Go is by having functions that return more than one value. And thankfully in Go, returning more than one value is a native property of Go. And what you do is you simply make a list of the return types after your list of parameters. So here, factorial will take an integer and it will turn an integer and something of type error. Okay, and error is a defined type in the system specifically for handling errors. Okay, so we're going to import the errors package, and errors allow us to create new errors if we want to. So the new function from errors will create a new error. So notice on our return values, we're always returning back multiple values. Okay, so we're returning, we have to return an int and we have to return an error. Now, if there's no error, we return nil for our error. Okay, and so every time we have to return two different things because that's what our function declaration says. So so we use nil as our null value. Okay, that's what it's called. It's called nil. And then this is how we receive multiple return values. Okay, you just do a comma-separated list of variables. Now, one thing I didn't note is that Go is very particular that you actually use every variable you declare. So if for some reason you were receiving a variable that you didn't use, you would need to call it with a special variable name underscore. Just the underscore character, and that tells Go that you're not actually going to use that variable, and otherwise Go will actually refuse to build your program if you have a variable you've assigned but didn't actually use. So then, if you notice in main, we're receiving both the result and an error value, and this is a common paradigm in Go for error handling. You receive both a regular value and an error, and you check to see if the error is nil. And if the error is not nil, you do something with it. And panic is a special function within nil that if you have a non-recoverable error, you can panic, and that will simply exit the program with the error message. So that's how you handle errors and multi-value returns. Now Go also has pointers. So here we show a pointer. So this is a function that will square a number, but instead of returning the value, it's going to overwrite the value with the squared value. So notice here that we're declaring the parameter as a pointer to an int. Okay, see that star int? That means x is a pointer to an int. So then, if we want to reference that value, you have to do star x. That says, please dereference x and give me what's in that it's pointed to. Okay. So then on the left-hand side, if you do star x, that means take the variable that's pointed to by x and replace it with what's on the right-hand side. Okay, so so the first line takes the contents of the value pointed to by x and puts it in y. The second line squares that value and stores it, overwrites the value that's pointed to by x. Okay. Now the way that you send a value, so here we have val set to 5. So val is an int, but we need to send it as a pointer. So you use the ampersand in front of your variable to say, don't send the value, send the pointer to the value. Okay, so that's what the ampersand does. So that's the way pointers work. Now, a lot of people, a lot of modern programming theory tends to frown upon pointers, but the real thing that they frown upon is C-style pointers, which are very unsafe. But Go pointers are very safe. So by default, everything in Go is passed as a value, and that's true of basic variables. It's also true of complicated structures. But the thing about pointers is that in most programming languages, they actually may be nothing but pointers. So for example, in Java, pretty much everything except the basic types are all pointers. What makes a pointer bad is when you allow programmers to do unsafe things with them. So for example, in C, you had the problem that you could treat the pointer as a number, you could do arithmetic on them, and that led to all sorts of trouble. And then additionally, because C wasn't garbage collected, it was unsafe to return a pointer to a local variable. But Go is fine with this because it is garbage collected, so you don't have that problem. So let me give you an example. So this is something that you should not do in C, but it's great to do in Go. Okay, so here we're going to have a function that returns a pointer to an integer. Okay, and so it's going to create a local variable, assign it the value 6, and it's going to return a pointer to that variable. So C gets that pointer, and we can dereference that, and all is well with the world. If you try to do this in C, you could likely wind up with errors, because what would happen is that in C, local variables are stored on what's called the stack, and the stack goes away when you return from a function. In Go, all your variables are garbage collected, and so that means that they don't go away until you stopped using them. And so this way, it's perfectly safe to return a pointer to a local variable, because that local variable doesn't go away necessarily when the function terminates. It goes away when it's no longer in use. Now, Go has structs instead of classes. So a struct, the difference between a struct and a class is that structs are more oriented around the data than they are around the functions. And classes are more oriented around the functions than they are around the data. So here in Go, you actually basically define the struct as being the list of fields and types. Okay, so there's no commas, and you don't specify any default values. You just put in one field per line. So notice that the type names and field names are normally capitalized, and then they're actually passed by value. So if you do, if you have a struct as a parameter, it's actually going to copy that whole struct when it calls that function. Okay. Then if you want to reference a member of the structure, you just use dot notation. So if P is of type person, P.name references the name field. Now you can also pass by reference. So this points, you pass in a pointer to the person, and so now you can access the original record modification. So in that first, in the first print name, if I were to have modified something, it actually would not have modified the structure itself that from the calling function, because I actually have a copy. But in print name by reference, I'm passed a pointer to the person. And so if I were to make modifications here, it would actually be reflected in the original structure. But notice that even though we're passing a pointer to person, the compiler can still figure out that if we do p.name, that I really wanted to dereference the pointer and then do .name. So the compiler is smart enough to figure that out. So to initialize a value with that structure, we can do it like this. So we say p colon equals person, open brace, and the fields. So notice that, so we're doing colon equals, so that means the compiler is going to figure out the type of p. So the name of the struct with an open brace means that we're giving it a literal of that struct. And then we do field name colon value comma. And notice that even the last field will have a trailing comma after it. So this is important. This will bite you if you forget about it. There's a so even the last field takes a comma. It's a little unusual, but it works. So then Go also has arrays. So now Go arrays are not actually often used. What's usually used in Go is called slices, but we're going to save slices for another video. But I did want to talk about arrays because arrays are kind of a more basic type than slices. So to declare an array, you say var and then the name of your variable, and then in brackets you put in the quantity of your array and then the type of your array. So this is an array of 3 strings. Okay. Now when you declare a string, all members are set to their 0 value. Now we'll talk about 0 values in a minute, but basically every type has kind of a 0 value. But you can also set the value of an array element like you might expect. You just put in brackets the index. It's a 0-based index. And likewise, you can utilize an array element in the same way. So you can also do static initialization like this. So this creates, so int list, notice that we're using assignment, so the compiler auto-infers the types. We're doing an array of 4 integers, and then we do an open brace to, since we're doing literal values, and we're literally putting in the 4 values that we want inserted. And then the len function will return the length of an array. Okay, so that's how arrays work. So note that arrays are always passed by value. So if I were to pass an array from one function to another, that would literally copy the entire contents of the array. And as I mentioned, arrays are rarely used in Go. Usually we use slices. They look similar, but they actually act a lot different. So Go also has maps or hashes or dictionaries. They're called a lot of different things. They're called maps in Go. So the way that you declare a map is like this. So you do map, and then in brackets is the type, that's the key, and then after the closing bracket, you have the type that's the value. Okay. Now the interesting thing about maps is they're actually, even though they don't have a pointer star on them, they actually act as pointers. So if you don't give them an initial value, they'll actually start out being nil, not an empty map. Okay, so maps actually start out nil, not as an empty map. So you have to give them a starting value. So you can set values using a syntax that you're probably familiar with, and you can retrieve values in a similar fashion. So then since maps are essentially pointers, so even when you pass them to functions, modifying them will still modify the map. Now you can point them, you can pass pointers to them, it's just not quite as useful as passing pointers to other things. But notice if you pass a pointer to a map, you actually have to explicitly dereference the map before setting values. So you can actually refer to values that don't exist, and they will give you the 0 value for the type. And we'll go over 0 values a little bit more in a minute. But in a sense, for integers, it is literally the value 0. So if my map, we never set AAA, so when I look up AAA, it's going to return 0 because that's the default value for an int. Now, if I want to check and see if something exists, I can use this syntax. So I have value, comma, OK equals map. Okay, so what this does is this says, store the value from my map bar into value, and if you actually found a value and you're not just giving me a default, put true in OK. Otherwise, if you didn't find a value, put false in OK. And then you can say if OK. And so this allows you to check whether or not the value was really there. And this is another common paradigm. If something may or may not return a value, you oftentimes return the bare value in the first parameter, and then you return a Boolean in the second one, saying whether or not you actually found one. So those are kind of a couple of basic intro programs to kind of help you get your feet wet on how Go works and what the syntax looks like. A few more basic things about syntax. We talked a little bit about zero value initialization. So basically all values in Go have a zero value. And this doesn't necessarily mean the literal zero. It's just the value that they're set upon initialization if they're not initialized with another value. So for example, pointers will be set to nil, numbers will be set to 0, strings will be set to the empty string, and structs, they'll simply create each member with whatever its zero value is. So in Go, all the variables have some sort of initialized value. There's no such thing as accidentally using a variable before it's initialized, because it never is uninitialized. Now in pointers, you will have a state where it's nil, but that's still a understandable value. You'll never use it in such a way that there won't be a value. It'll always be set. So then there's also looping. Okay, so in Go, you only have one looping structure. They have the for statement, which is kind of a complicated statement for being the only looping structure. But Go made it flexible enough that you can use it in a variety of different contexts. So the for loop is the one looping construct. And so the basic way it looks is like this. You say for, and then you have an initializer, semicolon, a condition, semicolon, and then what to do after each iteration. And then you have your loop contents inside the braces. So the initializer is executed once before starting the loop. If it's a variable, you can create a variable that's only used within the loop. The condition is evaluated before every iteration to see if we can continue. And post is evaluated after every iteration. So your typical for loop looks like this. For I colon equals 0, I is less than 10, I plus plus. So this will simply iterate through the values 0 through 9. Now, you can shorten the for statement. The initializer and post can actually be dropped if needed. So if you just wanted to do a while loop, you can do it like this. So for I is less than 10, we've dropped the initializer and the post. And in fact, if you just want to do an infinite loop, you can actually just do for and then start open brace, and that will simply give you an infinite loop that goes until it breaks. You can also, if statements, you can have initializers. So in your typical if statement, you say if comparison, else, do something else. But you can also do an initializer. So I can say if a colon equals some expression, a is less than 10. Okay, so this will initialize a with a value, and a is only available within the if statement. Okay, so that is kind of the basics of Go syntax. Hopefully we covered enough to give you a flavor of it. There's still a lot left to cover, and we'll try to get to those in additional videos. There's a lot of things that we have to cover. We want to cover slices and ranges, how to add methods to structs, how to do polymorphism, how Go does concurrency, which is literally what Go is named after. Go is the concurrency mechanism for the language. There's additional Go syntax for case statements, for type safety, There's a lot of little details to cover. The Go packaging system is really cool, and the Go build system and tools are really cool. You can get it to auto format your code, and there's all sorts of fun, little fun things we can do with Go, and we'll hopefully get to in future videos. So anyway, so that's Go. I hope you enjoyed it, and I hope you pick up the language and give it a try.